Okay. Hello. Welcome to the stream. And today we're gonna do some Rust. I am going to introduce our project, and then we'll see where it takes us. So the project I'm working on today is this. To be succinct, this is a little command line utility that may output something that looks like something you might have seen in Unix. It's your content of your directory in the tree diagram. Well, as you can see, it's a little bit different. If you have seen tree, TREE, before, you'll notice some differences between the output here and what you get if you run that. You notice there's colors of different file types, and there's a little number in front of each output. And let's see if I want to pick. Let's see what. So for cargo.toml, for example, the number is 3. So if I type E3, and that opens that file. So that's a little feature I call editor aliasing. So it's kind of like, you've seen the content of the directory, and now what, right? Now you can follow up with editing. So yeah, so that's I guess in a nutshell what this command line utility does. Or there's also other things like, files that are ignored by Git will not be shown here. You notice that there's no target or any of its content in here, right? But if I actually look at the content of target, there's a bunch of stuff in there. If I'm interested in that stuff, I could just look at it by, I believe it's -S. It's either -S or -, yeah, so S, I guess, stands for simple. As you can see, there's nothing simple about this directory. There's actually a whole lot of content in there. But normally that is not a thing, right? Because target is a temporary directory generated by cargo, and in this project, it's ignored because it's temporary, right? So we ignore this content. Anyways, so yeah, that's a brief tour of Tree, our little tool that we're gonna work on, and it's written in Rust. It's been a while since I worked on it, so I guess one of the first things we could do is just go over how this is written, and maybe think about what we want to work on. I mean, I have some ideas, candidate, and we can start with something simple potentially. Anyways, okay. So I guess I'm not using clap for argument parsing. It's a guess, but it has a pretty good chance. Also, probably want to increase the font if I can. How would I do that? I thought it was this, but oh, I'm pressing the wrong button. Okay, let's make the font big and nice for the stream, and potentially, some people may be watching it on their phone or whatever. So let's make it readable for them. All right. Okay, let's go over the code. Yeah, so I guess main just calls into this run option thing that gets us the option, so we can take a look at some manual parsing of options, I suppose. Pretty simple stuff. We just take the vector of strings, and then we convert it into, I guess, this option object, right? No, that's the standard option. Option object is this one. Yeah, so we have, I guess, the editor to use, and then there's a mode thingy, and then there's root. Root potentially should be the directory that you want to display, right? So let's take a look at the mode. So there's follow, get, ignore, makes sense. Exclude hidden files, makes sense. So these is like, yeah, I guess help and version are in here. So yeah, interesting. If I would written this today, I would use clap, but not sure converting to clap is something we want to do. Could be something. Yeah. And then once we're done getting our option returned in this line, I suppose. Yeah, and if there's any errors, we would just return a help, run help, right? And then we just call this run method a function that takes the option and do some stuff, right? So yeah, I just switch on the mode and yeah, okay, cool. I can see just from this brief overall review that I need to do some refactor to do some of the things I planned for today. Yeah. So let's pick a path and keep looking. We have follow, get, ignores, for example. This is like the default kind of option if you provide an input path. And then we just call into this path finder thingy. I guess that'll give us a list of paths. And then we format the path into a result, right? And then we output the result. And then potentially create the edit aliases. Create edit alias is writing a text file in the temporary directory. So yeah, print entries. Okay, so one of the things I'm hoping to do is, instead of output the tree diagram into the terminal, I could output, say, JSON, right? So I can see us just take the result. Let me see what the result is like. Formatted entry. Oh, so this is one thing that we may need to change, right? Like the result is this representation, which is just a bunch of strings. So I can see that change if, say, our result end up being a JSON value. Okay. All right. So let's think about what we can work on. So I have a bunch of issues. Some of them I filed today in preparation for the stream. We can start with some simple stuff. For example, this one. Can I specify any directory hierarchy or tree, just any directory or some special file type, right? This is a totally reasonable feature. And yeah, before I would begin, let me just make sure the app builds fine. Do I have a makefile here? Okay, so we can do make check or make setup even, but make check probably is the okay, makes sense. So it looks like everything's in order. All right. Okay. So yeah, this is probably a good warm up. So instead of displaying files, this user wants to be able to see only directory hierarchy or any special file type. So that's actually two separate tasks, right? We can list only directories, or we could list the let's say we take a pattern, file pattern, and just list anything that matches the pattern. So the second one is interesting because it requires pulling like a regex library or roll some kind of our own thing, which obviously is not a great idea. So let's do the first one first. So I have AESVH. So what would a directory flag look like? We could use D directory. Maybe. Well, let's think about. I guess before we design the thingy, let's do this. So there's file, directory, and link. That's all we are concerned about for now. So we could support, in theory, listing. I guess it doesn't make sense to list only files, right? Because files belong to directory. In order to have a tree structure at all, you can't just ignore the directory. Otherwise, it doesn't make sense. Kind of. Yeah, if you don't list directory, then yeah, it's weird. Okay. So let's do directory only. Yeah. Okay. So let's dive in a little deeper into how things are implemented. Oh, this is a big function. Ooh. New. Returns a thing called a file tree. File tree, it's thingy with, it's a storage called file. I guess file has a path, has a type, and then it has type specific data. And type specific data is enum that has file or directory or link. Directory link has their own payload. Okay, so this is kind of like the node of the tree, and then file is kind of like file is like the node of the tree, and then the data thingy is the link to its children. That's one way to think about it. Yeah. Okay. So interesting. This is a useful abstraction, I guess, especially when it comes to translating to a new kind of output format. Okay. So I guess when we create a tree, file tree, let's take a look. Okay, so we use a slab. I have a feeling slab let's do some research. Okay, so there's 2 point releases of slab already. Maybe that's the first thing we could do. Let's go to the release notes and check out what has changed. So 1 bump version, so that's not very helpful. Changelog. Wait, really? 1 and 2 are. Did I write this before 2018 July? Prove reserve and reserve that. Implement default for slab and slab drain. Okay, it doesn't really affect us, but I'm guessing it won't hurt to try to update it. Maybe this is our first change today. Wait, cargo build. Cargo, what is it? Update? Cargo update. Oh, a bunch of things changed. Is that good? Part of the danger is like we have Windows support and I'm running it on a Mac. So we'll have to rely on CLI to verify things. Slab. Why isn't slab updated? Oh, it is updated. Wait. Oh, maybe I have been using 0.4 and the minor version gets auto updated. Okay. I mean, still, this is still a good change. We got an update from WinAPI, and then we got update from minor updates, hopefully, from libc, Hermit API, WinAPI. Yeah, minor updates. I'm just gonna take some assumptions here, make some assumptions here, and say minor update are probably okay. I don't know. Wrong cargo. Take. These are. Oh, while we're here, maybe I can also update the branch name, default branch name. Okay. Let's ask CI if this is okay. Yeah. Let me think about this. Yeah, that's one thing we could do. But I'm gonna check the status of my stream real quick. I haven't done that. Should have done that earlier. According to OBS, everything's fine. Okay. OBS, everything's fine. The stream title is totally wrong on YouTube. And it's unclear to me what's going on Twitch. Okay. All right, Twitch looks fine. All right, I need to fix things on YouTube. One sec. Actually, probably easier if I just hide my screen a little bit. Sorry about that. Ah, I know what's happened. It's this streaming platform. Stop. Sorry, it's my only my second time streaming on YouTube, so I'm not. I'm learning. I'm learning. Okay. Save. Okay. All right. So it looks like, yeah, as predicted, minor updates for various things are okay. Actually, yeah, I'm gonna log this into this minor version as well. It's not a big deal. Okay. Yeah, maybe I should do the default branch thing. Because we're on master, would be nice if this is main. So let's take a look at what that could mean, right? So if I look at things in here, we have, I don't think master matters here. What about release? Okay, I can worry about this later as well, but okay, so it does check out the default branch, so I think we're okay. All right, so let's do it. Since this is just an application, I'm not too concerned about people depending on the branch. Not too concerned, a little bit concerned. It's just easier to, let me think. Formula, homebrew formula, not this one, right? Homebrew core, maybe? So let me just check a few things, such as the formula for homebrew core. Let's see how that works. So tree command dot ruby. Yeah, this just downloads a tarball, so it doesn't matter what the branch is. So that's good. We're also in things like Nix packages. So we can take a look at that. This could be a big download potentially. Oh. Let's look. So how does this one work? It fetch from GitHub v. So this looks like it's getting it by the tag, right? I hope so. I mean, the point is it doesn't rely on master. That's a good thing. Either it fetch on tag or it goes to the release and get a tarball. Yeah. So yeah, I think the last place I'd like to check is like scoop main for Windows. But I believe over there it's even simpler. I think this could just be a pre-built binary even. Wait. Is it not in here? Scoop main, yeah. Wait, I could swear it's in scoop main. Bucket. I thought it was in strip main. I can't find it in here, so that's interesting. Scoop. Pull requests closed by me. Ah, the remote is wrong. That's why. Whew. Okay. I think it's git remote set URL. Okay. And then we get this. Git remote set URL origin. Okay, so how does this work? It grabs the zip file and probably just unzips it, right? Because this is a pre-built binary. Okay, cool. So I think what we've done is eliminated the concerns about renaming the branch. So let's do that. Check out master. Let's make a main branch, push it. And then I need to go to the settings in GitHub and do a bunch of stuff. So I'm gonna turn off my display capture for this for a little bit. Unless, oh, let me just to be sure. Oop. Okay, branches. I guess for now these steps are okay. Branches. All right. So select this. Say that's the. I think the next step probably require passwords. or no. We're done. Okay, that's easier than I imagined. Masters no more. Long live main. Okay, so now what? Now I remember to, for my show notes. Okay. Now let's write some code, right? Let's write some code. So where is the option defined? Run option. Yeah, like I said, it's been a while since I worked on this, so the file organization is all very puzzling because normally I, my day job is Swift, right? So things are like a little bit more object oriented and less chaotic like this. So for a thing that's called run option, I would expect is in a file called run option, right? If you have a thing called tree, a file tree, it's probably in a file called filetree.swift. But here we're all cramming everything into the file tree thingy, so that's very confusing. But run option, I assume it's gonna appear somewhere. Good thing is we have jump to definition here. Okay. Okay, this is a run option. So I guess things like output format is a new category of run options. But the good thing is run option is it's more like a implementation detail, so we can be flexible with it. So I guess I'm gonna add work on this feature. Let's just make a branch for it first. All right, issue number 30. I'm just gonna call it. Wait. Okay. So let me think. We're gonna add things like output by specific file type. We may also add things like, only list specific file type, output in JSON format, show include like file size, in output. So these are the potential things we want to add in here. It does seem to me like all three of these are orthogonal to each other, right? So there's no point adding things like like an enum or an option set or something. You can just simply use booleans for these. Yeah, so this could just be list directories or directories only. I don't even remember how bool is spelled in Rust. Okay. And then, yeah, so there could be a JSON. And, we can start with bool. And then if there's other formats in the future, we can turn the bool into a enum or something. Yeah. Okay, one thing at a time, though. So this requires me to update some call sites. Oh, haha. Oh, mine. It's been a while. Okay. Okay. Easy enough. And then let's pick a number, or pick a flag for it. Oh, so I'm using getOps. I'm using a library. I'm not hand rolling everything. That's good. I guess we can go to getOps. Nice. So it looks like latest version is 0.2, and we're using 0.2. Yeah. Awesome. Okay, so what do we want to call this new thing, right? This is where we design our interface. We call it D. Actually, I wonder what tree does. Maybe we can just follow their example. -D, yes. Okay, so D, let's call it directories. Directories Okay, that's fine. Only list directories entry output, something like this. If I cargo run -h here, we'll see. Yep, that's one of the options now. Okay. Now let's get that one out. So here we first get our mode, and then we get the editor value, we get the root value, and then we should get the directory value as well. Directories only. Should be matches option present D. Okay. Okay, easy. And then we take that option, we use it here, right? So I guess the easiest way to do it is get the directory only option and then give it to all these the pathfinders. Yeah. Okay. Option directory only. Okay, and then we just give it here. Like this is one of, I imagined this to be easy, and I picked it as the first task as a warm-up, and as you can clearly see, I needed it. Okay, so that's going here and add that option. Only it's bool. Okay. Okay, let's get it. So the nice thing is we're getting the metadata for each entry with walk dir here. And work dir does let us filter things. Okay. And it gives us this entry thingy. And then we can look at look at its documentation. Walkder Rust. I assume this is our entry, but I also seem to remember there are, oh, follow links is another direction option we can add. Is hidden. Okay, let's look at what's other entry here. Their entry. It does have this file type method, but we also later get the metadata directly. And I believe file type calls metadata first. I mean, on the underlying POSIX call is the same. It's like stat or lstat. So, hey Eduardo. Yeah, so since we're manually getting the metadata already, I think we're gonna be okay. So if meta, I don't know what metadata has, so let's take a look. Metadata file type is dir. If directory only and meta is dir is false, we can continue, right? Continue is a thing in Rust, I hope. That seems easy enough. Same thing here. And this guy calls this guy. So that's already good. Non-git ignored paths. Oh, this is a little tricky because we're calling OS files. So this might not work. Let's take a look. Cargo run. Yeah. Well, yeah, I didn't add the option. So let's add the option. The option is -d. Yeah, it didn't work. But if I do -s-d. Yeah, so this is working. As you can see, we're only looking at the directory now. And we can even add more stuff and it should just be just fine. Yeah, okay. So I want to look at git OS files a little bit. Does it have options for directories? Non-empty directory. Hold on. Git OS files. Okay. What if I say directory? That doesn't make sense. Git os file list only, list directory only. One level is not what I want. List directories, yes. Yeah, you can get the dir name and unique it, but yikes. Okay, doesn't seem like there's a built-in solution, so we can manually filter it. It's not as bad as, you know, because we're already shelling out to a different process, so it's already pretty slow, right? So what's a little more reading of metadata, because we're reading it anyways. So wait, let me look at how this works first. Oh, this is just a fallback. That makes sense. That makes sense. Okay, so here I'm basically processing the output directly, but I'm reading the metadata here. Okay. So we take the metadata of P, which presumably is path, and then we're mapping it. We take the path, convert it to a string, and then we also take the file type. Yeah, metadata is -m. Okay, okay, okay. So this is pair. And then we will have to do this pair if directory only. Wait. Filter map means if I return none, it won't be in the result, right? Okay. If I feel like there's a simpler way to do this. So I use map here because metadata returns a result. Okay. And then map also returns a result, right? But filter map expects an option. So let's take the result. The problem is that I don't want to deal with errors whatsoever. So converting it to OK is correct. But what other options should I chain it with? I think it's and then. We take the pair. And here we say if the second value of the pair let's do it this way. So I'm going to take the whole metadata here, right? And then we call and then here. And then we can say this is a pair. If the pair's second data is, this might not be the most efficient way to do it, processing power wise. If directory only and this is there is false, we return none. Else, we return a new pair, which is p.0 and was it file type new? p.1. How about this? How about this? Oh. No? Wait, how does this work? Oh, right. I think you do something like this, right? Yeah, you're right. It's capitalized. You're totally right. And I think that's why it wasn't. Okay, cool. Format this so it looks reasonable. All right. I have a feeling this is not the most idiomatic way to do it. We take the result from metadata and then we're like, and then we do this, and then because the outside is a filter map, so we're saying if the condition is not met, filter it out because we're giving you a none instead. Otherwise, we proceed. But isn't this just another filter map? I guess we don't have filter map because it's not a iterator. But I wish there's a filter map. But add then does the job as well, so maybe I'm overthinking this. Okay. Swift run, not Swift run, cargo run. Oh, get rid of -s. That doesn't seem right. If it's directory only and the output is not a directory, return none. Filter map can be done. Couldn't it be done with another filter map? Yes, if the first filter map returns the metadata, but like if you need to have two consecutive filter map, you might as well just do everything inside the first one, right? So I think that's that's my opinion. But something is wrong, right? Directory only, which this is true, and the metadata claims is not a directory, then return none. Otherwise, we return some results. Well, where are my results? That doesn't make any sense. Oh, wait. What's going on here? You only put the semicolon on statements. Oh, yes. That's right. But what was the other error? I guess this is equivalent. I don't know what I was thinking. Right? These two are equivalent. So that's not the problem. Yikes. I'm so confused. There's something weird. Oh, I think it's because I need to add parentheses here. Yeah. Okay. It's a syntax thingy. That confused me a little bit. Yikes. Okay. Okay, things are, there are things here. Okay. True. Everything is true here. So this is true for sure, but that means the second clause is also true, which is interesting because it can be, right? P.0 is the path name. P.1 is directory. Ah. Yeah. Okay. That makes sense. Ah. Okay. So this is not the correct place to do this abstraction, unfortunately. Yeah, because ls files only give you files. For these other ones, we're good because we're starting with a root directory. Therefore, we do iterate over these directories and we can filter there. But in this special case where we use ls files as input, that approach doesn't work. Oh, this is turning out to be an actually interesting problem instead of just something that I can warm up with. Okay, so let me just undo everything here. Okay, take a step back. First of all, I noticed this is probably redundant, right? Or not? Oh yeah, collect. Okay. Wait. So there's LS3, and it has a -d option. Yeah. Okay. 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 All right. So I need to take a step back because we collect the paths, right? Some of them is from OS files. Some of them is from walking the entire directory. And then in format path, we run the formatting. So this happened to work with OS file. Because we need to break up a path into components anyways. And we know that anything that's not the last component is a directory. So when we run formats, we just, let me see. So format path is a little algorithm where we get the root format file result. Yeah. Let me take a look at formatted entry again. Okay. So potentially we can do some filtering over here. No, this is weird because, yeah, this is too late because here we already inserted a prefix. Prefix is these stick characters, right? So for this file, the prefix would be these characters. And the prefix is dependent on the location of this entry in its parent, right? The first guy, well, the last guy gets a different prefix than the first guy. Interesting, interesting, interesting. Format paths. So we have a root and we have paths. Interesting. This could be a potential bug. We're assuming the path encoding is UTF-8 and we're running on Windows, so that could sometimes not work. That's one thing we need to look out for. Okay. So the new thought I have is like, if we assume git ls file give us recursive into subtrees, maybe this is okay after all. Yeah, this is okay. This works. We just use a different git subcommand. Oh, root is interesting though. Root. So root is a directory, but ls tree, does it take directory? It doesn't. It takes object names. Right? Yeah. Oh wait, it does take a path. What was I thinking? We take head and then we can add more stuff to here, right? Yeah. Oh, yeah, totally works. I'm overthinking this. Okay. Whew. Okay, so the git command is if directory only command something, otherwise this command. So new, we still want to run git, and then we add a bunch of arguments here. First argument subcommand is ls tree, and then we give it a little bit of sub command. So flags, we want recursive, we want directory only, we wanted to run it against head, and we want it to limit things to root. Okay. Kill me. Silly Rust. Right. I think. Oh, yeah. This is coming back to me. So I think there's a different initializer we can use. This Fluent interface has yeah. You need to basically do it like this. It's imperative actually. Yeah, the silly thing is I am using a lead binding, right? It's just it couldn't figure out that it's in this condition. No big deal. I think I can do command. Maybe make this a little imperative. Aha, okay. Okay. Git command output. Wait, it still doesn't like this. All right, let's consult the documentation. Git, not git, rust. Okay. Command. Yeah, I don't like. This is not what I want. I want the way the thing you create a command first. Oh. This is just silly, but okay. All right, so the last thing is I need to also not include this part. Does git iOS tree have us covered? Name only? Yay, name only. Oops. Hey, that's what we want. Finally. Okay, interesting. We learned a little bit about Git today. Okay. So I think that means we're done. Let's do a couple of more experiments. Make sure things are well behaved. Maybe even go to a little slightly more complex directory, like, I don't know, this one. And then, yeah, that was debug, right? And then we can run -d and look at this beautiful directory only thingies. What if we go -s? I hope that's more stuff. No. Yeah. Just by rough visual inspection. Okay. Nice. So what do we do? This is add directories only of option which limits output to only director. Nice. Maybe the reason was the semicolon again. So I don't get why it was being dropped. So the value that's being dropped is the intermediate value. So I actually kind of understand it. Pass. Was this in this file? Okay, so what's happening is these arg functions, they consumes the previous value. So it takes ownership, right? It's moved. So each time you call this, it moves the previous value. So now you need to take over it. Yeah, actually that doesn't make much sense. Yeah, I thought I had it. Okay, let's take a look at the signature again. So this is arg, I can just go here. Right, it takes a mutable reference of self. Yeah, and then it creates a new command. You think the reason is the semicolon again? I think previously I wasn't using the semicolons though. When I wrote it as this, declare a variable there, or even I can just say something like this, right? And then the first line would be, oh, I can probably keep this here, replace, oops. I thought, right, this would work, I thought. So according to, I mean, at least if we take the Rust compiler's explanation, this is a temporary value, right? So after we call this guy takes ownership of this, and then this gets freed. And it creates a temporary value that gets consumed by this guy, and it got freed. Apparently, the compiler thinks that this syntax means we're assigning the first value to this variable. as opposed to the new values. So it's like operator precedence kind of a thing. Yeah, the dot has a the assignment has a higher precedence compared to the dot. That's probably that's my guess. Wait, I'm doing something wrong here. Hold on. Also, it's very sketchy that I don't have unit tests. I'm just manually testing the result. But this program, at least when it started out, is pretty simple. So whatever. Add direct option to show directory only. Oh, actually, we get to say close this number 30. Boop. Wow, that took an hour and 40 minutes. Yeah, I think the Git investigation is what threw me off. I think is my understanding of how things work was wrong. Okay, so this should reference this issue, right? Yeah, nice. The next thing I kind of want to work on is this. So tree from Indiana State, apparently. Actually, what surprised me is they have pretty active releases throughout the years. So that's pretty interesting. And the first release dates all the way back to question mark 90. Back in the good old days where I guess you don't even care of any sort of metadata for your project. Yeah, so this is the option, right? So you can get your output as a JSON object. Yeah, the golden question mark days. So outputting JSON is interesting because obviously we won't manually construct the JSON string value. Also, I personally think that this white space thingy is cute, but it doesn't make. I mean, I don't know. Like the whole point of the program is kind of give you a, I don't know, visually pleasing output. So I understand why you would output your JSON, format your JSON in this way, but I don't consider JSON a super human readable format. You know, debatable. That's a debatable statement. So I guess I'm trying to think whether I want to give it this kind of visual distinction between the parent and child, or I can just dump out the JSON, right? That's one consideration. The other thing is, I guess we have this formatting thingy. It is this format entry thingy. But format entry is already lost the relationship. It's the result of walking the file tree, right? Now it's just like a ready to display format. So this is not adequate because I'll need metadata for things like whether you're a directory and who are your children. That data is available somewhere in here, but it's like used and then thrown away. Yeah, maybe it's this file tree thingy. Let's see, file tree again. Oh, yeah. Actually, I mentioned at the beginning of the video. Yeah, it's this file object. File object, for some reason, has an ID. I don't think it matters. Oh, it matters because the ID is the pointer in the storage. Interesting. Yeah, this is a software archaeology. Like, this is code written a year ago, but it's already seems like someone else wrote it. Okay. Yeah, so a file has its identity, it has a link to its parent, and then it has its actual path. It has a display name. We can include all of that in our data, JSON data. Has a type. What's interesting is there's file type and then file types specific data, and they somewhat overlap. I assume I have both because of convenience. Sometimes it's easy to just tag it. Sometimes I need the associated data, or rather, the associated data is generated in a later time. Yeah. But it does seem like file tree. Yeah, it does seem like this is what I need. Streaming on YouTube. Oh, hey. Yeah, I'm trying things out, I guess. Glad you found me. Wait, I'm actually curious. How did you find me on YouTube? Because I never tweeted out the. Oh, I guess maybe you follow me on YouTube. I mean, subscribe to me on YouTube, and somehow I showed up on the subscription when you browse. Okay. So I'm trying to understand how the slab thing work. I know the slab is used to, because we are dealing with a tree with back references. So you can imagine in Rust, that'll be a challenging thing. So somewhere the circular references is not playing well with the vanilla quote unquote Rust model. So the slab data structure is introduced to work around that, right? But now it's like I kind of that's almost like a guess, right? It's a educated guess. I wrote this code after all, but the problem is I don't recall the specifics of how things work already. For example, right? I assume there's some kind of there's a thing called vacancy retrieve, vacant entry, and a key. So assume when you put things into a slab, you give it a key. So I'm just gonna go over all the references to a slab and see what happens. So we get this key thingy, and then we insert a box that is our file, okay? And then is slabs reference anywhere else? Okay, so here we're taking, okay, so slab is kind of like a, yeah. So there is indeed a key, an ID thingy. And then I assume this gives you the entry from a slab by its ID. Child key. Oh, child key is my thing. Okay. Right, so vacant entry gives you the new ID. Okay. Does file conform to some kind of protocol or something? Trait, I guess. Because I'm giving the new ID directly to this file. So that means when I insert this file object into the slab knows that this ID is the ID I previously asked it to give me, right? So does that mean file conforms to some kind of trait? Oh, okay, I'm just gonna read the documentation now. Rust slab crate. All right, have a good evening. Okay. Wait. That doesn't make much sense. File. Storage slab. So assume insert gives you the ID. That's why you can get it out like this, right? Wait, how am I using this? So I use this vacancy key thingy. But I'm not inserting with this syntax. Entry.insert key and value. So all I'm doing is I get the vacant entry.key, right? And then I just call slab.insert. So presumably, if this works at all, that means when you call vacant entry.key, I mean, it's internally a vector, right? So this key is just a indexing the vector. And when you call it like this and then insert, immediately follow up with an insert, it will insert into the same entry. Slab is back to the vector. So I'm a little concerned that this is not documented, even though things clearly is working. Or it could be like something changed in the documentation. Hi, William. What's the task at hand? I'm working on my little command line tool that displays things in the tree diagram and lets you open the one of the things that's listed in there. And right now I'm trying to understand some pieces of its implementation so that I can implement a JSON output as opposed to that diagram. That's a high level thing. And the program is written in JSON. The program is written in Rust some time ago. So I'm kind of trying to recover some knowledge that I used to have about it. Okay, so vacancy entry. New ID. Yeah, so it appears that every time I ask a key from vacant entry, I insert something into the slab. But it's almost like I'm abusing something that's not undocumented. Oh wait, I think I was misled by the documentation. The documentation here inserted a tuple including the key, but that's not necessarily. Oh yes, yes. This is just the data structure of choice, entry of choice, which is a pair that happens to contain the key. The key is being here is incidental, right? Because all you need to do is get the key before you insert anything to the slab. No, no, it's different because it gets the entry and it inserts into the entry. It is different. I should probably follow that pattern. This confuses me a little bit. Okay. So really it's like root entry is slab.vacant entry, and then we take the root ID here. Okay. And then here I should call entry.insert. Root entry. According to the documentation, this is the API. But for some reason I'm using, yeah, I'm doing something weird. I don't know. Oh, yikes. All right. So new entry is this. Okay. And the new ID is new entry.key. And we insert it thusly. It is more verbose, right? So maybe somehow I did more research and realized this, like the fact the previous thing works. I don't know. If only the old me wrote documentation. Okay. Oh, by the way, let's check our previous pull request. Okay, things looks okay. There's only one commit, so I can just rebase and merge, right? Okay. Eduardo, thank you for. Well, it's kind of great that you were stuck on it. So you're saying the command problem is because the argument function returned a mutable borrow instead of own object. Yeah, it returned a reference. Yes, you're right. It returned a reference to the previous previous reference, I guess. So what we were doing is we create this value, give its reference to arg. Arg takes the reference, do some mutation, and return another reference. Yes, that makes sense. So the original object was never, yeah, the original ownership, the ownership was never transferred. It just it's a temporary. It's like a temporary variable or automatic variable, gets referenced a bunch of times and goes out of scope. That makes sense. Okay. What should I call this? Update slab usage to in accordance to docs. Not sure how the original use pattern came to be at this moment. Whatever, something like that. And I guess I should make a pull request for this as well. I also want to run some manual, like not having a good coverage is a problem, but it does seem like things are okay. I don't know. Okay, it appears that the only thing of any significance to do here is to convert this file into a JSON output, right? And the tricky thing is we're storing things in a slab. Well, that's one of the tricky things. The other one is I never actually used the, or I believe it's called like Sir D. So presumably I'm going to depend on this, but I assume since we're going through the slab, I'm going to have to do a lot of customization. Any valid data, JSON data can be manipulated in the following recursive enum representation. Blah. Okay. A string of JSON can be parsed into a value. Yes, of course. From slice, from parsing. What about serialization? Parsing JSON as. Nope. The other direction. Constructing JSON values. So it has a macro, and it's just some sugary stuff for you to make literals. Creating JSON by serializing data structure. This is what we want. To string and to vec. Okay. So this derive business probably won't work with us. There's a good chance we don't use this at all. But I do want something that helps me with, let's say, escaping values. Setting up. Import derived macro as use serialize within the same macro and write serialize. Serialize is what I'm interested in. Yeah, you can derive. Awesome. But it won't work for me, I assume. So we can give it a try. Dependencies, Serde, JSON 1.0. I think it's like version equals this and features equals derive. Okay, let's fetch the dependencies. Oh, it's not part of JSON. That makes sense. Quote. I may end up just using this. I mean, it'll be amazing if for some reason we can just derive a conformance given that we have a slab. Oh no, there's no way. No. This doesn't make sense because the data structure itself is not aware of the slab, right? It's just yeah, I'm storing the U size as ID. That's all. Yeah, so 38 won't help me at all. Not thinking straight. Okay. But the quote crate does interest me a little bit. I don't know. How do you... Was it just docs.rs? Okay. Let's look at quote. Nope. That's not what I thought it is. I hate to have to manually do this though. Does Rust have something like protocols? Yes, Rust has traits, which is similar to protocols. The thing I was looking at before, Serde, that package actually can automatically derive, basically synthesize conformance to protocols, and one of them being serializing and deserializing from JSON, from and to and from. Yeah, so it's kind of similar to codable. What is this? Hold on, string. JSON string encoding. Let's see. Character encoding. "12 character sequence encoding the UTF-16 surrogate pair." Default encoding is UTF-8. Okay. But it's just a little absurd that I have to do that myself. maybe a better way is I convert this data structure to a simpler data structure, right? Convert this data structure to a simpler data structure that can be handled by Serde. Okay. And that one is simpler because I don't require things like back references. Everything will be just a strict top to bottom tree. Maybe that'll work, right? So something like, actually, maybe something like this. No, not something like this. Simpler than that. Sounds reasonable? Yeah. I think that's a better way than me traversing this tree with, working around the slab data structure and manually write out strings that happen to be valid JSON in every way, right? That seems doesn't seem like a very attractive path to take. Yeah. So what would be a simple data structure that something like Serde can handle? Let's call it a enum, right? Let's call it an enum. Let's call it serializable tree. Okay. And everything will have a name, a path, a file type, and an optional link, and children. Well, it's an enum, so not everything will have a children. Okay, so we could have file could have a name, right? File could have a path. Can you have a nested type declaration in Rust? No. Okay. So we'll just take some inspiration here. Obviously, this is not the direct analogy, but we can learn things like we should use map for mappy things. We can use vec for things like children, right? And then this enum value, I presume, if I write my own type that's in this shape, is serializable, right? So I could have a file, serializable tree file. It'll have name, path, type, I guess, but and that's it. How do I escape keyword? Like this? R. Okay. Yeah, I wonder what this will give us. So there's file, there's link, and then there's directory. And the differences here are link will have an extra value here, and directory. Hello? Error will output. What does that mean? I have no idea. And directory will have children. I'll have to make sure these names are what I like, as in the, because they're part of the output. Okay. So here we get some recursion going. Serializable link and directory, serializable directory, right? So one of these needs to be boxed. Or both of them. I don't mind. Okay. So the directories, why does my thingy keep saying this? Surdy can natively understand these three structures, I'm guessing. That's my hope, and we will find out right now. I don't know what's going, why, I'm not sure why when I save files, Vim is acting up like that. Something is weird. What gives? Do I need to? end this session or something. I don't know. Try to play with your environment and blah, blah, blah. Size things up. Save? No, same thing. What does that mean? What does it mean? Can I just Visual Studio Code for the rest of today? I don't know. Ah, nice thing is you can increase is usize an on-type pointer. No, usize is just the integer, just like size t, similar to size t in C. But its purpose is here is a pointer because I'm using it. I get this value from a special data structure called a slab, which is just a glorified array. Yeah. Okay. Well, I guess we'll try to write code here, and I have Vim binding here, so I'm not too bothered by it. We get, and to be honest, I think it looks slightly nicer as well. Okay. So I'm gonna add back the 30 thingies. Blah. Okay, I think I remember what I need to do. Serde, and this is a table. First value is version 1.0. Second value is features. Features is an array. First, then value is derive. Okay. And then we also need Serde JSON. Serde JSON. Well, I don't need this yet, right? Look at that. Look at this. Okay. Now let's see what we can do here. Use Serde. I don't know what's in Serde. Serde, I assume serialize. Okay. Then go down here. I mean, these are, I assume, can just work, right? Just do derive, serialize. I think things are happy here. Oh, I also forgot all the keyboard shortcuts here. How do I Visual Studio Code? Terminal is shift. Oh, is it control? Okay. It's control tick. All right. That's good enough. Okay, so yeah, of course, simple things like this can work. And wait. Ah, that makes sense. Okay, so I think the compiler is happy about this. What I don't know is what it would actually output. Wait, I also don't remember whether I need to make things public. Like, can I reference that here? No, right? Or maybe I can. Oh, right, right. On declared type, so maybe I need to mark them public. Public. Okay. Now it's like, wait, this is a very interesting thing is like, I think you need to save files manually here. Really? That makes sense because it should be like this. Okay. Okay. All right, so we can play with these conformances now. But now I do need to point insert a JSON, right? So let's do that. So I should construct some of these values and see what the output JSON is like. Hopefully it's just like very nice what we expect, and then that's good for us. Let's take some examples. Constructing value, creating by inserting the structures. So what do we do? these relate just like this, okay? Use Saturday JSON result. Okay. And here we say Saturday JSON toString. Okay. Give it a reference to n. And then I presume that's a result. Yep, it's a result of string. So we can just straight up like that. Comment. Oh, I don't have my shortcuts here. Comment these out. What is this? Oh, it's not link. It's path, right? Makes sense. All right, let's just do expect or just unwrap, I guess. We're just playing with it. Oh, all of this needs to be public. Do these need to be public? No, right? Okay. Modules in Rust are so confusing. Okay, so we've just serialized a struct that we made into a JSON string, and this is the output. Has a name, as a path, as a type. Every single value is a string, which is what we want here. Okay. Let's make. I mean, this is not anything out of ordinary. What I'm really interested in is actually the tree thing. So let's do a tree is file type, file tree of serializable tree node. Oh, as an enum, so we can further refine it into a file, and we give it the value of n. Now here we can just print out this, and we'll see what that gives us, right? Okay. Oh, YouTube compression being weird? Interesting. Huh. Now it's taking the case name and use it as a key. I don't like that, right? I don't like that. Is there a way to customize the behavior? There must be a way to customize the behavior. Or rather, like, I don't even care about how to customize the behavior. I only care about how to achieve my result. Maybe I can just Google this. Asserted JSON, no enum name. Enum representation. Okay. Flatten. Thank you for the suggestion. I will definitely remember that, because yeah, I guess what I really need to do is to actually read the documentation, right? Flatten. 30 flatten. Flatten. Let's Google it. Struct flattening. Inlines keys from a field into the parent struct. Okay. Consider pagination API, which returns the page result along with pagination metadata. This is how many results are returned. How far into the blah, 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 blah. Okay. The page may look like this. You know, blah, 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 blah. And then you have the actual data, right? And there's a list. Same scheme with limit, and offset, and total. Okay. So you have the pagination object. And you have the users object. It's convenient to factor the common pagination metadata field into a shared struct that can be flattened into each API response object. Really? Why would you want that? Capturing additional fields. Field map. Actually, let me read this first. Enum representations. Externally tagged. Default representation is externally tagged. Yes, that's what I just saw. Glad it's is a default. Internally tagged. Written JSON syntax. The internally tagged representation look like this. So they said internally tagged tag equals type. That is what I want. Adjacently tagged. Untagged. Interesting. So there's I guess I have a few options here. I can use lowercase stuff, right? But I'll get a warning. Yeah. Which is awkward, right? Because ideally I would want this. This is actually exactly what I want. Except I don't want the type to have uppercase values. Wait, what's this? Tag equals T, content equals C. Oh, okay. It's pretty interesting because you're reversing the key and value when you look at this and this. Okay, I guess I'll use onTagged then, right? OnTagged is what I'm looking for. Serde OnTagged. Which means probably need to import OnTagged. Nope. Maybe not. Okay. Let's continue our experiment. File tree, serializable directory, name, directory, path, a directory, type, directory, children. N. Or is it like a box N or something, right? So that's an interesting error. I wonder how should I overcome this? Doesn't have a size and compile time. So maybe it should be box, and inside are references. Is that better? Right, now we have to add lifetime, which is not a big deal. Is this the syntax? Okay. I think the compiler is happy now. No, this is not good enough. Oh, box new. This is yeah. Makes sense. Okay. Right. How do you construct a literal expected slice? If I add children, like this, what's in the bracket? So this is a vector of reference of that inside the box. Inside the box. Like this? I mean, that, yeah, I think I started to do that, right? But it complains about expected slice from reference. I don't know if Rust enough to do this. I feel silly. Ah, so when you say that, you literally means this. You mean literally this. That doesn't seem right neither, right? Expected slice from reference. Why would I expect a slice? Missing closing paren? No, I don't think so. Right, children dot dot, I get that. I get this. This turns a vector into a vector slice. But that's weird because I mean, I didn't declare the type to be a slice. This is a vector of references to the tree node, right? YouTube channel is too delayed. I'm sorry. Yeah. Wait, so how do you construct this value? That makes sense. The box of vector identity contains a slice, I believe. For vector, it would need to be vector t. I see. So I could try to remove this. It still gives me the same error. I don't know. Oh, did I do something silly here? Nope, same thing. I don't know why it expects slice. Children expect slice found vector. Expected this. Oh, wait. I think I know what you mean. I don't know why I thought this is correct. Oh. Welp, the Swift programmer in me is like, that must be the syntax. Expect enum node found file. Okay, that's a much more straightforward thing, I think. Okay, so this would be file tree, so the serializable node, file, wrap that in here. Okay. I wrap this into this, give this in here. Now I serialize this. Oh, finally. I think we're on the right track. Finally. This needs to be boxed, right? Okay. I don't see any squiggly line. Hey, it built. And we've got name, other, path, type, children. And children is an array. Inside. Yes. Okay. This is what we want. And just for fun, D2. Directory D2. I just want to nest it. Okay. Rename all lowercase. Really? Do I still have... Okay. Rename. Custom date format. Manually serialize. Enum as a number. Real value. Enum representation. Well, ideally, I don't want an extra field. Remember, I'm just constructing this struct just so I can serialize it. So like the less stuff in there, actually the better. Container attributes. Thank you. Container attributes. Ah. So let's give that a try. So I want to use this. Oops. Oops. Lowercase. And then combine that with tag equals type. Okay. What's this squiggly line? Unused, right? Okay. Type directory name. That's beautiful. Thank you, William. That's really nice, right? Oh, wait. Not so soon. But although I don't expect this to not do the thing, we accidentally learned a behavior where they actually, I guess, they did both. I had that field, I didn't really remove it, and then they also presumably also synthesized the field, and the value happened to be the same, so that worked out, right? And it didn't complain. Nobody complained. Nobody threw any error. I assume it's just, key value. Here's a new key. Here's a value. You have old key. I don't care. Here's a new value for the key, and the value happens to be the same. Yeah, that's really nice. Now the real challenge. I mean, this is obviously very good progress. I think I can probably beautify, right? Serde JSON beautify, something like that. Two-string pretty. Pretty, please. Yeah, I think I'll output this. Okay. This is a very good research. How long have we been streaming today? 3 hours. Okay. I think that's it for today's stream. Thank you so much for watching and suggesting solutions. I think, Rust stream is a little tough because I just every, let's say, 2 months, I will open a Rust file and write a little bit, so I forget everything. Let's see what Eduardo is saying. Eduardo is saying, you may not need the box on the box vec tree. Vec will do. Let's give it a shot. Well, let me try to think through this, right? So you're talking about when a directory has children. So maybe the vector itself has a fixed size already. Yeah, thank you very much, Eduardo and William and anyone else who is watching. So no box here. That makes sense. Vector is a kind of a box, right? Yep, that worked. All right. Thank you. See ya.